This is section 2.8, distance and midpoint formulas, and then we are going to relate those distance and midpoint formulas to circles. We'll start with 2.8.1, the distance formula. If you remember back to previous math classes, you will remember that you can find the length of the hypotenuse of a right triangle using the Pythagorean theorem. A squared plus b squared is equal to c squared. And if you solve for c to find that distance between this point and this point, then you get c is equal to plus or minus the square root of a squared plus b squared. Of course, because we're dealing with a distance can't be negative, so the plus and minus doesn't matter, and you get c is equal to the square root of a squared plus b squared. So now we are going to relate that to a line on a graph in the Cartesian plane. So if we have our coordinate plane here kind of drawn okay, and if we have a line on there from this point to this point, then we have 2 points. One has a coordinate at x1 and y1, and the second one has a point at x2 and y2. So those are the locations of the endpoints of that line. Now, if we turn this into a right triangle, let's just put a dotted line in here to go across and one to go down. There we go. Then we can see that we have the same thing that we just had when we had A, B, and C, right? Except now we have our A side is on the x coordinates and the B side is the y coordinates. So this side, the length of this side is x2 minus x1 and absolute value that, and the length of this side is absolute value of y2 minus y1. And then using this and the Pythagorean theorem, we can find the distance from one endpoint of this line to the other endpoint of this line. So let's go ahead and plug that in. We get the distance, or the length of the hypotenuse, is the square root of side A squared. Okay, so side A is the absolute value of x2 minus x1 squared plus the absolute value of y2 minus y1 absolute value squared. Now, we know that when we square something, it's going to end up positive. So we don't actually need those absolute values. So we can simplify the distance formula for a line as d is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared, and then make sure your square root symbol goes all the way over all of that. So this is the distance formula that you will be using right here. Make sure you notice that when you're doing distance, you take the difference of the two x coordinates and you take the difference of the two y coordinates. Okay, that's going to be important. Students always confuse those. You take the difference of the two x coordinates and the difference of the two y coordinates. So let's do some examples. Example 1. Find the distance between -1, 4 and 3, -2. And I've put a graph on here so that you can see what that looks like. Okay, so right here we have -1, 4 and here we have 3, -2, and we want to find the distance. Now, we could, because we have a graph to look at, we could count the squares and say we have 1, 2, 3, 4, 5, 6 on this side of our imaginary right triangle, and we have 1, 2, 3, 4 on this side, and then do the Pythagorean theorem. That would work, but it won't always be that simple as far as the coordinates are given or how long the line is, and so you need to be able to do it with the distance formula. So let's go ahead and plug it into the distance formula. Let me go ahead and rewrite the distance formula here. Distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, so let's go ahead and plug in. Now, it does not matter which x and y we call 2 or 1 as long as we're consistent. So let's go ahead and say that this is equal to the square root. We'll just go in order. So we'll say -1 minus our other x, 3 squared, plus, now our y's, 4 minus -2. Now this is where another place where students often get messed up is if it's a negative, remember you need to subtract that negative so it becomes a positive. So let's go ahead and simplify this. We have -1 minus 3 is -4 squared. And we have 4 minus -2, so that means 4 plus 2, so we have 6 plus 6 squared. That simplifies to 4 times 4 is square root of 16 plus 6 times 6 is 36. And then that simplifies to square root of 52. And then we can simplify this radical. 52 is equal to 4 times 13. So we can pull out that 4. Square root of 4 is 2, and that leaves us with the square root of 13. So that is how we use the distance formula to find the distance between two given points. Now you are going to try it with this checkpoint. Find the distance between -4, 9 and 1, -3. So go ahead and solve that out, come up with an answer, and then continue to see if you did it right. So let's go ahead and plug this into our distance formula. D is equal to square root of -4, and then I'm going to go ahead and use the 1 plus 1 squared. Sorry, that should be minus. I specifically told you to watch out for that, and then I made that mistake. -4 minus 1 squared plus 9 minus -3 squared. Okay, let's go ahead and solve this. We get the square root of -4 minus 1 is -5 squared plus 9 minus -3, that's 9 plus 3, so that's 12 squared. That equals the square root of 25 plus 144. So then we need to add those together. We get the square root of 169 and the square root of 169 is 13. So that would be the distance. So check your answer that you got, see if you got it right. If not, work through it again and see where you went wrong. The next concept is finding the midpoint. So this is 2.8.2. Now we know how to find the distance between 2 points, and we're going to then find the middle of that line on the graph. In order to do this, we plug into a formula that looks like this. Midpoint is equal to x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2, and parentheses. Notice we have parentheses, we have one value, a comma, and another value in there. Once you solve this, it's actually going to give you a set of ordered pairs. It's going to give you the x-coordinate of the midpoint and the y-coordinate of the midpoint. Notice, as I said before, on the distance, you take the difference of the two x's and the two y's. For midpoint, you take the sum. Okay, so don't confuse those. For distance, to find distance, take the difference of the coordinates to find midpoint, take the sum. One thing you'll also note is that you have one x value plus a second x value, and then you divide by 2. You also have one y value plus another y value, and you divide by 2. So think back to what you've learned in math. When you have two values that you add together and then you divide by 2, what are you doing? You are averaging those. So you average the values of each pair of coordinates. To find the x-coordinate of the midpoint, you take the average of the x's on the endpoints. To find the y-coordinate of the midpoint, you take the average of the y values of the two endpoints. So keep that in mind. Okay, let's go ahead and try this out. Example 1. Find the midpoint of the line segment with endpoints 1, -6, and -8, -4. And I've given you a graph here, and you can see we could solve this visually. We know that if the y goes from here down to here, then the middle is going to be on this line. And we know that if we go from here over to here, we have to go halfway between there. That's 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have to go 4.5. 1, 2, 3, 4.5. And there's our midpoint. Okay, so let's go ahead and solve that algebraically now. We'll rewrite out our midpoint formula. Midpoint equals, remember your parentheses, you have to put in parentheses. We're going to do the x1 plus x2, that's a plus, ooh, that's not writing very well, sorry, x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2, and end parentheses. So let's go ahead and do this. Our first x is 1, and our second one is -8. 1 plus -8, divide that by 2, comma, y's are -6 and -4, -6 plus -4 divided by 2. We'll simplify that. 1 plus -8 is -7 divided by 2, comma, -6 plus -4 is negative 10 divided by 2. And then of course we want to reduce any fractions that are reducible, so we end up with negative 7 halves and negative 5 as the midpoint. And if you look, that is exactly what we came up when we did it graphically. Always reduce your fractions. You can leave it as negative 7 halves. You could turn it into a decimal point, negative 4.5, but might as well just leave it as a decimal if that's what you start with. So let's go ahead and have you try that with a checkpoint. Find the midpoint of the line segment with endpoints 1, 2, and 7, negative 3. Go ahead and solve that using the midpoint formula, and then check your answer once I solve it out. To solve this, we're going to go ahead and plug it in. M is equal to, and I'm not going to rewrite the formula this time, M is equal to, my x's are 1 and 7, 1 plus 7 divided by 2. My y's are 2 and negative 3, 2 plus negative 3 divided by 2. 1 plus 7 is 8 divided by 2. And 2 plus negative 3, that's 2 minus 3, is negative 1 over 2. And then I have to simplify, so I get 4, negative 1 half as the location of the midpoint for the line segment with endpoints 1, 2, and 7, negative 3. So check the answer that you came up with. If you didn't get that right, make sure you understand what you did wrong.